All right, we are going to be practicing those trig function derivatives for day 2. Okay, and here's what you have to remember. Our rule of thumb is if you see multiple trig functions, so if you have multiple trig functions in your starting equation, I'll just say function, then you have to check to see if it simplifies before you start derivative. Check for simplification before you start your derivative. This is what we spent last year in trig, that chapter 5 with all of those trig identities. We did a ton of simplifying. They just don't get nearly as complicated here, but you have to remember all of the stuff. And all of that stuff is on that blue sheet on the trig side. So let's just get started so you can see what I'm talking about. So first one, p of x equals secant x multiplied by cotangent x. So again, 2 different trig functions in our original function. Does this simplify? Well, we're going to find out. Remember, our one rule of thumb we could follow was we would switch everything out into sines and cosines. Cancel. Let's see if anything cancels. So remember, secant is 1 over cosine. So this is memory, or look on that blue sheet. It's the reciprocal identity. Cotangent, yes, it's 1 over tangent, but I want to see sines and cosines. If you look, cotangent is cosine over sine. So now I do see that I can cancel out my cosines. The only thing I have left, that's 1, times by 1 over sine. 1 over sine goes back to cosecant. So my original function can be simplified down to just cosecant. Now I can do derivative. Now it's much easier than doing the product rule that was there. So derivative here, cosecant's derivative. If you look on your blue sheet, I don't have one handy here, but it's negative cosecant times cotangent times the derivative of the angle, and that's just a 1, so that doesn't need to be there. So negative cosecant cotangent. If you forget and just jump into product rule, you're going to have an answer that's equivalent but will look nothing like this, and that'll be -2 on your quiz and test. So simplify first. Number 2. Let's go h of x equals 4 cosecant 3x times tangent 3x. So again, multiple trig functions. We're going to simplify first. If it simplifies, not everything will, but I believe this one does because I handpicked it. So 4 is staying a 4. Cosecant is 1 over sine. Tangent is sine over cosine. And the sines do cancel. So we are left with our 4. That's 1. 1 over cosine goes back to secant. And notice I haven't called this a derivative. All this is h simplified. So this is still h of x. Now I can keep track of where I'm at. I can say, oh, now I'm ready to start the derivative. By looking at my notation, I know I haven't done derivative yet. Now I am. So the multipliers carry along. Secant's derivative is secant of the angle times tangent of the angle multiplied by the derivative of the angle, which is a 3. And then just floating that 3 to the front. Final derivative is 12. Secant 3x, tangent 3x. Okay. Number 3. Let's get into some fractions so you don't do some bad algebra with those. We got y equals tan 2x over sine 2x. Okay, again, multiple trig functions. Got to ask yourself, will this simplify? You're not going to know until we try. So tangent gets rewritten sine over cosine. So that's just tangent. Sine is going to stay sine. And I'll put that over 1 because I've got fractions within fractions. So see this as fraction divided by second fraction. Rule is multiply by the reciprocal. So we will keep this fraction the same. Multiply by this reciprocal. There is some simplifying that can happen. So we are left with 1 over cosine, comes back to secant. And that's all still just y. Now we're ready for derivative. Secant 2x times tan 2x times by derivative of the angle. Float that 2 to the front. Okay, number 4. F of x equals 6x to the 4th over sine x. Okay, does not have multiple trig functions, so no simplifying. I do see x divided by x, so it's just an old quotient rule. So quotient rule, we take the derivative of the top, which will be 24x cubed, multiplied by the bottom, minus, keep the top. Derivative of the bottom is going to be a cosine x times 1, all over bottom squared. Okay, basket factoring isn't necessary. The only thing I can cancel are signs, but they have to be in all 3 baskets. There's some in this first one, but there are no signs over here, so you cannot cancel. That is bad algebra to do that. Has to be, you would have to be able to basket factor it out and then cancel. You can't just take it from one of the 2 baskets in the top. So that is done. Number 5. Y equals 3x times 1 plus tan squared x. Okay, I only see one trig function, but again, take yourself back to last year. If you've got a squared trig function with a plus or minus 1, this could be one of your Pythagorean identities. And I'll grab mine. I don't have the blue sheet, but the blue sheet came right out of the book. If you take a look at your Pythagorean identities, right, can I get this any closer? Right here, 1 plus tan squared does equal a secant squared. Remember, the cosine squared plus sine squared is 1. cotangent squared plus 1 is cosecant squared. So anytime you've got some squared trig functions, check out your Pythagorean identities to see if it simplifies at all. Because remember we used to kick these around. You could have cosecant squared minus 1, that would equal cotangent squared. So anyway, we've got 1 plus tan squared, that simplifies to secant squared. So we've got our 3x times secant squared x. And now we are ready for a product rule. Because we've got an x term multiplied by a second x term. So we've got our u and our v. So y prime, take the derivative of the u times by that, plus, keep that, multiply by the derivative of secant squared. Again, if you write it like this, you can see that there's an outside and an inside. So 2 comes down, subtract 1, so that gives you secant to the first, then multiply by secant's derivative, that is secant times tangent, okay, simplifying, this basket's going to stay exactly 3 secant squared x plus this one's going to turn into 6x. I've got a secant times a secant that'll combine and make a secant squared. Oops, secant squared x tan x. And like I said, I don't think the author basket factors, but if you see parentheses in the answer, you're going to know we basket factored. And if we just practice, we would take out a 3 and a secant squared. That would leave a 1 here to get that back on the distributive property, plus 2x tan x. Like I said, I'm pretty sure he doesn't, but just in case, we'll practice one. Number 6. Oh, here's a trickster one. Sine of sine x. Now, you might think this is a double trig function, but take a look. How many x's do you see? There is only one x here. So this is not a product rule, and this is not a simplified trig function. Not product. There are not two x's multiplied here. Not a trig simplify, because there's only one x value. So this is just a regular, straight up, normal derivative. So what you have is a trig function, sine, with this being its angle. It's the sine of an angle. So we start from the outside as this sine. So derivative of sine goes to cosine. The angle stays the same. So now we've done the outside derivative. Now we're going to, this is the angle on this one, but this angle has a trig function and an angle. So, starting here, derivative of this, outside is the trig function, so that's cosine x times derivative of the angle is a 1. Not that you need that. So, there it is. I can just get rid of the 1. Okay. Last two are setting up story problems in your book. Number 41. We've got a flashlight pointed at a wall and then rotating the flashlight up. And here's the situation. You are standing here with a flashlight. The flashlight is 10 feet from the wall. And then you're going to rotate this flashlight up, making this height change where the amount of light is and the angle change. And they want us to write an equation for y, but we're doing trig function. We're writing a SOHCAHTOA equation. So we always stand on our angle. Y is on the opposite side. The 10 is on the adjacent side. Opposite and adjacent, that's your tangent. So to write an equation relating these three pieces, you would write tan x equals opposite over adjacent. And then just to get it to y equals, you just multiply by 10. So y would equal 10 tan x. So part A was just asking you to verify that that equation was right, and I wanted to go through the review of that so you can finish that problem up. And then our last one is an antiderivative. If I tell you the derivative equation is secant squared 5x. And the trig functions I do think are the harder ones to go backwards on. Oops, this is derivative. So we want to go back and figure out what the original equation is. So remember, you're always just asking yourself, well, what equation, when I take the derivative, gives me this? So is there a trig function that has secant squared as its derivative? So you're going to look at your derivatives. Which equation had secant squared as its derivative? I don't have my sheet here, but if you look, it was tan. But remember, we want to leave a space for a coefficient that we might need. But we know our equation has a tan 5x. For sure. So we start here and see if we need a multiplier here. So we're going to do the derivative of this and see how close it is to that. So if I was to do the derivative of tan 5x, it would be, start here, that would be secant squared 5x. Timesing by the derivative of the angle would be 5. So if I left this as a 1, our derivative would be 5 secant squared 5x. Well, I don't want that 5 there. I want a 1 there. So I need a multiplier that's going to cancel that 5, well, and that's just 1/5. So if I had the 1/5 there, I would carry it along, and then the 1/5 and the 5 would cancel. And then we need our plus c. And that's it.